Students, we move to the next topic, that is rolling motion. So before going for the rolling motion, you should know what is our translatory motion, or that is a linear motion, and what is the rotational motion. There is a huge difference between the rotational motion and the rolling motion. Try to understand this concept. I'm giving you an example here. Suppose I take one body on a straight path and I'm just pushing it. That object or the body, if I take and I'm just pushing it, what happens? It will have certain displacement on it. So which type of motion is associated with that? कौन सा motion है बेटा उसके साथ? The motion we can say translatory motion, because the body is moving from one point to another point under a linear motion. That is a translatory motion. That is one type of motion what we have already seen in kinematics. Now, if I take one object, a sphere or a ring, if I rotate about a fixed axis, like we can rotate a ring, we can rotate a disk, we can rotate a cylinder, we can rotate what I can say a sphere. So which type of motion associated with that? That is a rotational motion. Now, if I combine this rotational motion along with the translatory motion, what I am going to get? Just try to imagine what I am going to get. Here I am going to get the third type of motion, that is what you call it as a rolling motion. So under this concept of rolling motion, if you see clearly an object which is rolling, it is having the concept, or it is having what I can say the rotational motion, as well as it is moving from one point to another point, it is having translatory motion also. An example, the best example is a tire of a vehicle. You observe a tire of a vehicle when the vehicle is moving on a road. You can clearly observe that the tire of that vehicle is rotating about the fixed axis. That is what you call it as the instantaneous axis, I can say. It is rotating, and at the same time, while rotating, it is moving like this. That is, it is having the linear motion also. So combination of rotational motion along with the translatory motion, that gives us a rolling motion. Rolling motion की हम बात कर रहे हैं. तो यहाँ पे हम थोड़ा सा अंडरस्टैंड करते हैं रोलिंग मोशन कैसा हम उसको हम डिफाइन करेंगे, क्या चीज से हम मतलब ट्रांसलेटरी मोशन, हाउ टू कंबाइन ए ट्रांसलेटरी मोशन विद द रोटेशनल मोशन टू गेट द रोलिंग मोशन. एवरीथिंग वी आर गोइंग टू डिस्कस अंडर दिस टॉपिक. सो देखिए यहाँ पे जस्ट इमेजिन दिस इज स्ट्रेट पाथ, और यहाँ पे बेटा मैं जो है ना वन ऑब्जेक्ट आई एम कंसिडरिंग. You can see here, this is a one object, a sphere. Just imagine a sphere or a ring, whatever it is. Another here also, I'm considering one more thing. This is this. Now, this is what I can say. This is it is having, this object is having translatory motion. Translatory motion है. So translatory motion means this object, for this object, this point is moving in this direction with some velocity v, and this velocity v is nothing but, try to understand, this velocity v is nothing but the velocity of the center of mass. क्योंकि इस ऑब्जेक्ट को, कोई भी ऑब्जेक्ट को अगर आप ढकलते हैं बेटा, पुश करते हैं, तो व्हाट हैपेंस, यू नो, एवरी पॉइंट मूव्स विद द सेम वेलोसिटी, एंड दैट सेम वेलोसिटी इज इक्वल टू द वेलोसिटी ऑफ द सेंटर ऑफ मास. दैट इज द इंपॉर्टेंस of the translatory motion. So here this point, जब इसको हम ढकलते हैं बेटा, इस तरह से पुश करेंगे, that is what I can say. I'll write for you. This is the translatory motion. So under this translatory motion, what I observe, this point, if I take, it is moving like this. If I take this point, this is also moving with the velocity v, and this velocity v is equal to, what is this, velocity of the center of mass. और यहाँ पे बेटा इसका सेंटर कैसा मूव हो रहा है, ये भी वेलोसिटी v से ही मूव हो रहा है. ये पॉइंट कैसा मूव हो रहा है, ये भी वेलोसिटी v. ये वाला पॉइंट, ये भी वेलोसिटी v. You can see every point under this situation, that is translatory motion, every point is moving with the same velocity. Now what I do, I'll take another object here. Now if I take this another object, what I do here is I make it to rotate about this axis. So what happens, you know, at this topmost point, इसको बेटा इसकी velocity ऐसा होगा, linear velocity I'm speaking, because it is rotating like this. इस point का मैं velocity देखता हूं तो ये इधर होगा. It is rotating, I repeat. Okay, I'll write here. This is rotational motion. Now it is rotating, so it is this point is having the velocity in this direction, linear velocity. ये वाला point ऐसा घूम रहा है ना बेटा, तो इसकी velocity इधर होगी. और इस वाला, ये नीचे वाला point, the point which is in contact with the floor, it is having the velocity like this. And the point, ये वाला point अगर आप गौर करेंगे तो इसकी velocity कितनी होगी, जरा देखिए आप. The velocity is v. But if you see all the particles or the points uh, on the body, they are moving with the same velocity here under rotational motion. लेकिन एक point ऐसा है बेटा, यहाँ पे जो बीच में जो point हम consider कर रहे हैं, that is the center of mass, that will be at rest. That means it is having a zero velocity. Whenever you take a body in rotational motion, one point which is at the center, that will be at rest. वो move नहीं होगा. It will be at rest only. All the points will be revolving around that single point. I hope it is clear. Now, as I said, this rolling motion is the combination of this translatory motion as well as rotational motion. The very important concept what I am discussing here. So यहाँ पे देखिए बेटा, दोनों का combination है. Combination मतलब मैं क्या करता हूँ, mathematical की sign देता हूँ for your understanding. That means this plus this gives us what, क्या मिलने वाला है हमारे को. यहाँ पे भी दे देता हूँ mathematical की sign यहाँ पे आपके understanding के लिए. Translatory motion plus rotational motion. कौन सा motion आएगा आप मेरे को, that motion we are calling it as a rolling motion. So let us see how we are getting the concept here. So if I take this the object here, अब थोड़ा सा आप देखना है बेटे हमारे को, ये जो ऑब्जेक्ट है दोनों का कॉम्बिनेशन करने से जो हमारे को मोशन मिला है, दैट मोशन वी आर कॉलिंग इट एज रोलिंग मोशन. व्हाट आई एम गेटिंग, अ रोलिंग मोशन. ठीक है, तो अब आइए, अब मैं थोड़ा सा वेलोसिटीज की जब मैं बात करूंगा, दोनों को मिक्सअप कर कर, दोनों को एड अप कर कर, दोनों को सम करके क्या मिल रहा है. देखिए बेटा, ये वेलोसिटी v है, ये भी वेलोसिटी v है. And I told you v is equals to, because it is on the last point on the surface of the sphere, surface of the ring, this v is almost not almost exactly equal to vcm, that is the center of mass की वेलोसिटी होती है. ठीक है, तो बेटा अब जो है यहाँ पे आप गौर से देखिए, ये v और ये v दोनों सेम डायरेक्शन में है. Try to understand, this v both are in the same direction. So therefore ये ऊपर वाला पॉइंट की वेलोसिटी कितनी होगी अंडर रोलिंग मोशन, इट विल बी 2v. Now come to this middle point. इस पॉइंट पे आइए बेटा, यहाँ पे वेलोसिटी कितनी, 0, because in rotational motion the center point will be at rest. So ये 0 है, लेकिन ये तो v है ना, तो this v plus 0, how much it is, v. So under rolling motion ये जो center point होता है बेटा, ये कितने velocity से move होगा, v velocity से move होगा. Next come to the bottom most point. ये नीचे वाले point पे आइए, यहाँ पे देखिए बेटा, when it is moving completely, इस तरह से ट्रांसलेटरी मोशन जब हो रहा है, so it is having the velocity v. वही रोटेशनल मोशन में वेलोसिटी तो है, बट इट इज इन द अपोजिट डायरेक्शन. ये बिल्कुल अपोजिट है, एक दूसरे के अपोजिट है, बिकॉज वेलोसिटी इज ए वेक्टर क्वांटिटी. So what I do here is, if I take plus v, this I have to take it as minus v, and here how much is the velocity, 0. This is a very important point. Many times this question was asked, what is the velocity of a point of contact of a body with the ground when the body is under rolling motion? So we think about the body is under motion, the body is under having a rolling motion, how the velocity could be 0? But the answer I have proved it. This is plus v, this is minus v. The bottommost point will be having a velocity that is equals to 0. Now let us see this point. इस point की velocity कितनी होगी बेटा? So for that you can see here also, one velocity is exactly like this, straight towards right, and here this point is having the velocity down. ये same point की velocity क्या हो रही है, down में आ रही. तो let us see here and we will simplify it. देखिए बेटा, one velocity it is v and another velocity is v. How much is the angle here? Exactly theta is equals to 90 degrees. So two velocities are there here at an angle 90 degree. So what is the resultant velocity? To calculate the resultant velocity, I take the help of parallelogram law of vectors. So यहाँ पे हम बात करेंगे बेटा, v is equals to resultant velocity I am speaking, that is under root of, you know this, v1 square plus v2 square plus 2v1 v2 cos theta. Resultant velocity की बात कर रहा हूं मैं parallelogram law of vectors यूज करते हुए. So resultant velocity here you can see clearly, this is how much, one velocity is v, another velocity is v. So this is what, v square, this is also v square, plus this is 2 v into v, this is also v square. Try to understand, v1 is v, that's why I have written v square, v2 is also v, that is why I have taken as v square. लेकिन यहाँ पे देखिए बेटा 2 into v that becomes 2v square, and moreover the angle कितना है यहाँ पे 90 degree, cos 90. So what is cos 90? Cos 90 is 0. 0 into something is 0. So therefore this third term will become completely 0. ये third वाला term जो है ना completely 0 हो गया बेटा. जब ये third वाला term 0 हो गया, this is v square plus v square. I can write it as 2v square. So therefore क्या लिखेंगे हम इसको? 2v square लिखेंगे. और इसको थोड़ा सा सिंप्लीफाई करते हैं. दिस रूट टू एज इट इज v स्क्वायर, अगर हम रूट लेते हैं बेटा, स्क्वायर एंड रूट गेट कैंसिल, रूट टू v. सो देयरफॉर ये जो है ना बेटा, अब इसका रिजल्टेंट जो रूट टू v है, इट विल बी लाइंग इन बिटवीन दिस टू. तो ये जो है ना इसका रिजल्टेंट इस तरह से होगा, दैट इज रूट टू v. सो इफ यू सी क्लियरली हियर, this is like this what I have drawn towards right, and this is the same point it is having, for because of the rotation it is having the downward velocity that I have drawn down also. तो हमको resultant इस तरह से आ रहा है. So therefore ये point को तो मैं mention करूंगा, और इसके velocity बेटा इसी direction में बताऊंगा मैं. It will be like this, that will be root 2v. Now come to this point. You can see clearly one velocity is like this, other velocity is upward. That means one is right, other is up. So I'll draw here. This is right and other is what? Up. So how is the resultant velocity? Resultant velocity will be like this. So root 2 v. This is v. This is v. So resultant will be root 2 v. So it is like this. So therefore at this point, how is the velocity? You can see here, that is root 2 v. So in short, we can say that the rolling motion is the combination of translatory motion as well as the rotational motion. And in this, we have seen only the standard points. What are that standard points? I can say here, the topmost point, the bottommost point, the center point, and here the what I can say the diametric point per hum liye hai, theek hai, horizontal diametric points. What happens? What is the velocity if I consider this point? What is the velocity if I consider this point, other than this standard 5 points? So that will be our next topic. Now students, the next topic what we are going to discuss, it is the velocity. You can see velocity at any point, any instantaneous point on the rolling body. So what is this concept? Try to understand. So if I consider one object here, that is a rolling object, it is rolling. So here what I do, I know what is the velocity here. I know what is the velocity here. Just now we have seen here it is 2v, and here it is 0. Here it is root 2v, here it is v. But at any point, at any instantaneous point, what is the velocity? How to calculate other than these 5 points? Even for the formula or the expression what we are deriving now, it is applicable for every point. Okay, chaliye aaiye. So for that, what I do, I consider only this point. For this point, how much is the velocity? So for that, I take, this is the center, this is the angle what I am taking here. How much is the angle with the vertical this point is making? Suppose it is making an angle theta. Now because the body is in rolling motion, I will say here, I will write here, the body is in rolling motion. So because of rolling motion means because of rotation, it has some velocity, and because of what I can say the translatory motion, it will have some velocity. So that for translational motion, I take, this is the velocity v, and this v itself is nothing but the velocity of the center of mass. And because of the rotation, because the body is rotating, translational motion as well as rotational motion, so therefore it is rotating means it is having the velocity because of the rotational, and this is for translational. Now students, if this is theta 100%, this is also will be theta. Now I want to calculate the resultant of these two, that gives us the rolling velocity under the rolling motion. So how to move with the resultant? Here you can see the resultant for the rolling is equals to, this is for translational, that is translatory motion, velocity of translatory motion plus velocity of rotational motion. Now this is, I will write just vr, that is equals to, we can say this is vt, that is for translatory motion, but this rotational motion, you know, v is equals to r omega. We have already seen the relationship that exists between the linear velocity and the angular velocity. So that I'm taking the help here. You can see clearly this is v is equals to r omega in magnitude, but in vector form if you are writing v is equals to omega cross r, that only I'm taking here, omega cross r, where r is the radius and omega is the angular velocity. But okay, this is the expression what I have expressed. But how to calculate the magnitude of the resultant velocity? You know, magnitude of the resultant velocity you can calculate just by taking the help of parallelogram law of vectors. So this is what, how much it is, this is vt for translational, and you know translatory motion के लिए हम already हम consider कर चुके हैं बेटा, that is v, velocity of the center of mass. And here you can see that it is for the rotational motion, and this vr, this is what we have seen, this is r omega, and that is also equal to v only, that is the velocity of the center of mass. So ये भी v होगा बेटा, ये भी v होगा, और दोनों में एंगल कितना है देखिए यहाँ पे थीटा है. That is, we can find out the resultant velocity in order to calculate the velocity at any instantaneous point on the rolling body. तो अब हम calculate करते हैं resultant velocity. Pay attention. This is resultant under root of, you know the formula what I am going to use, v1 square plus v2 square plus 2v1 v2 cos theta. So here under root of, what is v1? v1 is v, v2 is also v. So therefore I take here, this is v square, this is also v square plus 2. What is this? v1 into v2, that is also v square, and this is cos theta as it is. That is under root of v square plus v square, this is 2v square, this is also 2v square, and this is what? Cos theta. So this is the expression, but let us simplify this. So what I can do here, I can take 2v square common. So here I'll write vr is equals to under root of, this is 2v square common, 2v square common, 1 plus cos theta, that is equals to under root of, this is 2v square, 1 plus cos theta. What is this 1 plus cos theta? 1 plus cos theta and 1 minus cos theta, I already have given you. 1 plus cos theta is 2 cos square theta by 2. 1 minus cos theta is also there, that is 2 sin square theta by 2. But here we are taking the help of 1 plus cos theta, so it will be just 2 cos square theta by 2. So simplify it. So 2 into 4, this is v square, and this is cos square theta by 2. So 2 का रूट 4 का रूट कितना होगा बेटा? 2 होगा, और this is v and this is how much? Theta by 2. So this is the velocity for a rolling body, and this is applicable, or this you can apply for any point. You can apply for the top point, you can apply for the bottom point, you can apply at any point to get the resultant velocity by using that formula. If suppose I'll just give you an example, if I take this point here, try to understand, if I take this point here, means this point यहाँ पे ले रहा हूँ बेटा, तो एंगल में कितना टर्न कर रहा हूँ? इतना टर्न कर दिया. That means how much is the angle now? 0. Try to understand. ये पॉइंट जब मैं यहाँ पे लेता हूँ बेटा, तो ये थीटा कुछ भी नहीं बनेगा. जैसा जैसा हम इस पॉइंट को इस तरह से लेते जाते हैं, then थीटा वैल्यू विल इंक्रीज, एंड एट दिस पॉइंट थीटा इज हाउ मच? एग्जैक्टली 90 बनता है यहाँ पे. ठीक है, तो यही पॉइंट अगर मैं यहाँ पे लेता हूँ, तो व्हाट आई एम गोइंग टू गेट? थीटा एज 0. So if you substitute in this theta 0, cos 0 by 2, 0 by 2 is 0, cos 0 is 0, cos 0, sorry, cos theta by 2, so 0 by 2 is 0, cos 0 it is 1, cos 0 it is 1. So 2v into 1, answer is 2v. So at the topmost point, the answer what we are getting as per the expression, it is 2v, and we have already seen in the general example, the topmost point will have the velocity 2v. In the same way, you can calculate the velocity at any point. I hope you have understood the concept. Students, now we are going to discuss the kinetic energy of a rolling body. As you know, the rotational motion is the combination of translational motion, that is translatory motion, and the second one is the rotational motion. So therefore, the kinetic energy of a rolling body is again the sum of kinetic energy of translatory body, translational motion, plus kinetic energy of the rotational motion. It's a very important concept that what we are going to see. See here, kinetic energy, I'll write here, kinetic energy, this is for a rolling body, that is equals to, I can say kinetic energy because of translatory motion plus kinetic energy because of a rotational motion. This is for translatory motion, this is for rotational motion. Now, what is the formula to calculate I repeat once again, what is the formula to calculate the kinetic energy when a body is in translatory motion? You know, kinetic energy is equals to half mv square. So this I'll write half mv square plus, when the body is under rotation, we have seen the dynamics for rotational motion. So under that, as I already told you, mass is will be replaced by I, velocity v is replaced by angular velocity, that is omega, that I am writing here. That is half I, and this is omega square. Half mv square plus half I omega square. Now students, what is this I? I is the moment of inertia and omega is the angular velocity. And you know the formula for moment of inertia. Here I'll write I is equals to, students try to understand this I, we have to take it as mk square. Mk square, m is the mass, k is the effective distance of all the particles, and in short this k we are calling it as the radius of gyration. I'll write the name here. K is radius of gyration, and we call it as the effective distance of all the particles, that is k. Now in place of I will write that only, that is half mv square plus half, what is this I is nothing but mk square, moment of inertia mk square. Now what is this omega? To express that omega in terms of v, let us see what we are going to. We know already v is equals to r omega, students. Relation between the linear velocity and the angular velocity. So v is equals to r omega. What is the value for omega from this? क्या मिल रहा है बेटा? Omega is equals to v by r. Omega is equals to v by r I am getting. So that v by r I'll write here as, this is omega square, so it is v square by r square. Now students, 1 by 2 mv square plus this 1 by 2, I'm writing in order, try to understand. This is m and here it is v square. So therefore I will write here mv square. What is left out then? K square r square is left out. So that I'm writing here separately, k square by r square. Now what I can take common from this? I can take common as half mv square. Here 1 is left out plus here completely half mv square is outside. So here what is left out? K square by r square. So this is the kinetic energy for the rolling body. Try to understand the kinetic energy for the body in translatory motion. It is just half mv square. Kinetic energy of a body in rotational motion, it is half I omega square. I am speaking about the kinetic energy of a rolling body, that is the combination of kinetic energy of the translatory motion as well as the kinetic energy because of rotational motion, and answer I am getting it as half mv square into 1 plus k square by r square.